All right, section 3.3. I was looking at the homework. It's like, okay, I need some more examples up here, some tougher examples. So that's why I'm making this video. All right, so let's say we have y is equal to e to the 5x tangent of 5x. And I want to take the derivative of this. I want to take dy over dx, okay? Derivative of y with respect to x. Now notice, all this is the exponent, okay? So what's the derivative of e to an exponent? E to the exponent, so I'm just going to copy down what I have here. E to the exponent times the derivative of the exponent times d over dx of this exponent. 5x times the tangent of 5x. Now, whenever I go to take the derivative of this, I'm going to use the product rule because we have a product. So this part just comes down. E to the 5x tangent of 5x just comes down. How about this part now? Let's see. We're going to have to use the product rule. So product rule says first times the derivative of second times the derivative of the second piece here, tangent of 5x, plus the second tangent of 5x times the derivative of the first times the derivative of 5x. All right, let's actually take some derivatives here and here. So I'm going to still bring out e to the 5x tangent of 5x times, now this part I bring down my 5x, but what's the derivative of this? Well, I'm going to have to use a chain rule. I have an outside function of tangent, inside is 5x. So how do you take the derivative using the chain rule? Derivative of the outside, which is secant squared, at the inside, at 5x, times the derivative of the inside. Now, if you're having trouble with this chain rule stuff, and you're not writing down this d over dx notation, I advise you to do so. It makes it so much easier. All right, plus, bring down this tangent of 5x. Now, derivative of 5x will be 5. All right, so I still have e to this exponent, 5x tangent of 5x. That comes down. These large parentheses come down. 5x comes down. Secant of 5x squared comes down. Now, what's the derivative of 5x? Just 5. Plus, and then I could say that's 5 times the tangent of 5x, like that. Now, I have some options here. I could say 5x times this 5 gives me 25x. Or I could look at it like I have a factor of 5 here, a factor of 5 here. So let me factor the 5 out to the outside here. And we get 5 e to the 5x tangent of 5x times, if I factor this 5 out, I'm left with this stuff, 5x secant 5x squared, plus if I factor this 5 out, I'm left with tangent of 5x. That's one way I can write my answer. Now remember, to input this into Wiley, you're going to have to put the secant of 5x like this, all quantity squared, because it won't let you put the square there. I can make sure I'm still in the shot. Yeah. All right, let's look at another one. What about this one? If I have y is equal to x cubed minus 9x squared plus 2 times e to the x like this. And it tells me to find the derivative of y with respect to x. Well, let's see. What I notice right here, I have a product, so I'm going to use a product rule. dy over dx is equal to first, which is all this stuff, x cubed minus 9x squared plus 2, times the derivative of the second piece, plus the second piece, e to the x, times the derivative of the first piece, x cubed minus 9x squared plus 2. Just apply the product rule. So this part comes down, x cubed minus 9x squared plus 2. Derivative of e to the x is e to the x. Because remember, the derivative of e to an exponent is e to that exponent times the derivative of that exponent. But what's the derivative of x? Just 1. Plus e to the x comes down. Now take the derivative of this stuff. What is that? 3x squared minus 18x to the first. All right, now I see an e to the x in this part and an e to the x in that part separated by a plus sign. So I'm going to factor the e to the x out. E to the x. So if I factor e to the x out, factor it out here, so I'm left with this stuff. X cubed minus 9x squared plus 2. Plus, if I factored it out here, what am I left with? 3x squared minus 18x. Now, let's add these two right here. We have an addition sign between them. So e to the x comes down on the outside. Now what's x cubed plus no x cubed there? Just x cubed. What's negative 9x squared plus 3x squared? Negative 6x squared minus 18x plus 2. There's my derivative. And I want to look at one more here. All right, let's suppose we're told to take the derivative of y with respect to x, and this time we have in parentheses x squared minus square root of x times 7 raised to the x as my exponent. Again, I have a product, so I'm going to use the product rule. So dy over dx is equal to first, which is x squared minus square root of x, times the derivative of the second, times d over dx of 7 to the x, plus the second, which is 7 to the x, times the derivative of the first, times the derivative of x squared minus square root of x. Well, this part right here comes down. X squared minus square root of x. How about this? What was that rule for taking the derivative of 7 to the x? Rewrite it as 7 to the x, or just copy that down, times what? The natural log of the base 7 times the derivative of the exponent, which is just 1 in this case. Again, how do we do that? If we have, like, say, a number to a variable exponent we're taking a derivative, copy down this exact expression times the natural log of that old base times the derivative of the exponent. Bring down this 7 to the x right here. How about the derivative of this stuff? Wouldn't that be 2x minus 1/2 x to the negative 1/2? Now verify that for yourself. Alright, so I'm going to say this is x squared minus square root of x times 7 to the x times the natural log of 7 times 1 is still just the natural log of 7, plus 7 to the x I'm going to bring down, but this part I'm going to rewrite as 1 over 2 square roots of x. Now, I could leave it like that. That's fine, okay? But I'm going to factor out this 7 to the x multiplied by both pieces here. So I'm going to take out the 7 to the x, and what am I left with? If I took this out, I'm left with this piece and this piece, right? So I'm left with x squared minus square root of x times natural log of 7. Plus, if I took this out, if I factored that out already, I'm left with 2x minus 1 over 2 square roots of x. Like that, close my large set. Now, I guess I could distribute this through here, but I'm not going to be able to collect like terms anyway. So I'm just going to stop here. Hopefully that helps with the homework.